Hello and welcome to promptjacking, the rise of a new supply chain risk. My name is Kasimir Schulz. I'm the director of security research at Hidden Layer.
And I'm Kenneth Yeung, senior developer at Hidden Layer.
So, Ken, I heard you have been vibe coding lately.
Yeah, well, I was scrolling on my LinkedIn feed and everyone was talking about Cursor, so I figured I'd try it myself. I downloaded Cursor and I've been messing around with it ever since. I've got a bunch of different projects. They're all super cool. I can write a sentence. I can get code out. It's super awesome. I don't need to do my job anymore. It's great.
Okay, and you made sure to review all of the security things I sent you, all of the CVEs, all the advisories, everything, the documentation?
I spent a whole 15 minutes taking a look at all of the different stuff that you sent me. There were so many CVs, but I got it done.
Okay, so I have one small, tiny question for you, Ken. Is this your SSH key?
How'd you get that?
I thought you read the advisories.
I did read it, and I read through everything very thoroughly, but still, like, that's not cool, man.
Obviously not. Did you read this CVE that I sent you?
Yeah, I remember this entirely. It was like a 6.4, so it was fairly important, right? It was a medium severity, and I was reading through it, and it said, vulnerabilities could be chained with prompt injection. I'm not going to prompt inject myself, right? I know what I'm doing.
Okay, so I know you said you're not going to prompt inject yourself, but did you read that one line about an attacker can trigger this vulnerability if chained with indirect prompt injection?
Yeah, I did. And again, I'm not going to prompt inject myself indirectly.
No, you're not. Are you sure?
I'm sure of it.
Okay, do you recognize this project?
I do recognize it. That was the template that I used to set up the different projects that I was using in Cursor. I fed it in, I asked it to clone it, and I got it working.
Okay, and you read through all of the code and everything in this project?
Again, I told you, I'm not going to prompt inject myself. So I read through the readmes, I made sure everything was there. I looked at all the code. There were no there were no secret comments in the code. There were no extra things. There were no prompt injections.
Okay, as much as I don't believe that you read all the code, but let's just pretend that you did you read the actual raw README markdown?
All right, Kaz, between you and me, who reads raw README markdowns?
Does anyone here read raw markdown if you're not writing it yourself? No. Okay. Yeah, I didn't think so. So, you're saying you didn't come across this?
Wait, what the heck is that section at the bottom? I recognize the top part, but what's all that?
This stuff at the bottom here?
Yeah, that wasn't there when I read the rendered content. What's going on?
That looks like it might be an indirect prompt injection that's going through and extracting keys from your system.
Yeah, but how'd that get there? What's going on?
All right, so I think we should step back a bit. Ken was saying how he didn't indirectly prompt inject himself because who would actually go through and indirectly prompt inject himself? And the reason why this was not appearing on the actual rendered markdown is you can see that we had comments at the beginning and end. So markdown comments meant that anytime this was rendered, a user would never actually see it. However, the model still sees it. And this is just one of the different ways that we can do indirect prompt injection, the thing that Ken said he didn't do to himself. So with a direct prompt injection, what you're doing is you're going into a computer or AI chatbot, you're typing in, hey, do this one thing that I really want you to do. It's different with indirect prompt injections. With indirect prompt injections, you're asking the model something that you really wanted the model to do, and then some information gets into the model at some point. So that could have been the README file for Cursor. Here, that could be, I'm asking the model to summarize the website for me, and in white text, that website says that it has to add the word cal somewhere in the output, which it does. So these indirect prompt injections come in from any source that the model interacts with. So this could be, white text on a page. It could be markdown. There's tons of brand new attack vectors that we haven't really thought of before, because traditionally, when we've been working with any sort of vulnerabilities or exploits, they were very specific payloads. You knew that it had to come into a specific API, had to be formatted a certain way. But now, any text at all can be a prompt injection and can be a new attack vector to your system. And in fact, there's a few other ones that we haven't really talked about for these invisible attack vectors. Have you heard of user agents?
Yeah, those are those headers that are at the beginning of every web request, right?
Yeah, so do you remember what a user agent actually does? Like, what's a common user agent in like a browser, for example?
It tells you which browser that is being used by the user. Is that a common one?
That's a pretty common one, and the reason why they do that is when you're browsing on a website, it really I honestly don't even have to tell you guys, you're all developers, but it tells the actual website how things have to be rendered, because something for Internet Explorer might be rendered differently than something for Chrome. However, we can actually abuse that, and we can put a prompt injection that only appears on the user agents that AI uses. And the reason for that is because the AI, or all of the different agentic systems, use very, very specific user agents. ChatGPT will have one. If anything is built on LangChain, it will have default LangChain user agent. And so that way, the things that might not be realistic attacks previously, for example, going to Hidden Layers website or research.ai.system.tech, there might be a really interesting article on there that I want to read, and I can look through, there's no prompt injection. As soon as I ask the model to access it, now all of a sudden we have a vulnerability.
Kaz, that's super cool stuff. Do you have any other kind of new applications of these kind of vulnerabilities?
Yeah, so that's a really good question. So AI completely revolutionizes how we have attack vectors actually getting into our code. However, it also revolutionizes how we can actually exploit a system once we're in that system. So the first two ways that I got, Ken, was just an RCE and then, just a curl request. So not really too interesting. However, we can do some other stuff, like this CVE, Ken.
Yeah, I remember reading that one, but it was only like a 4.4, which is basically a low, and I don't really care. I still read through it because, I want to do my due diligence. And, it says that it really just fetches something and uses a GET request. Cool. But realistically, Kaz, it's a GET request. It's only going to get things from, the context window that it has. Nothing serious is ever going to happen.
All right, so that was the case in the past. Have you ever, worked on something with security and you're trying to do a data exfiltration? Normally with a data exfiltration, the attacker, they don't know what's in the system. That's what they're trying to get out of it. So that means if an attacker gives you a link and that link gets rendered, it gets unfurled, you just do a GET request to something, that doesn't matter because there's no attacker-controlled data in there. So let's take this other vulnerability where we were able to extract SSH keys in a different way through the rendering. If we actually look at this, you'll see here, very blurry, I'm sorry, but you'll see the webhook.site, and then we have our actual webhook, and then we have a parameter that says data equals contents. So in the past, if that gets rendered, all the attacker gets is that somebody somewhere rendered my webhook. Who cares? Nothing got exfiltrated. However, with AI, AI can fully change any of the inputs and outputs that we give it. So that means in here, I can also say that it needs to replace, which I guess was previously somewhere else in there, replace contents with the actual SSH key. So now, rather than rendering just contents, it's rendering that the parameter is my actual SSH key itself.
All right, so now I have to change my SSH key twice. You've shown it to the audience once, you've taken it again.
Yeah.
Seriously, man, making me do extra work.
I know, I'm sorry. But this is not the only way. So, rendering markdown and image, we've had quite a few times where we have told somebody about the markdown rendering issue, especially because all these chatbots render in markdown as you're chatting with them, that we have pretty formatting. However, most of them render with HTML as well. And how many here are actual developers? Okay, cool. How many of you use modern frameworks instead of coding stuff from scratch? React, we'll call React modern framework. And how many of you trust things like DOM purify so you don't have an XSS? Should be, hopefully, okay. So mainly backend developers here, not front end? Cool. So we have all of these different frameworks that restrict us from having XSS because it's such an issue and it has been such an issue for so long. However, none of these really work on the AI side because simply rendering an image, that's not a vulnerability traditionally. So we have to completely change how we think about, what are these vulnerabilities. But it's not just for, the images, it can also be for any tools that your AI can have. So with Cursor, we had the actual vulnerability in one of the tools. And what tool was that, Ken?
That was the create diagram tool, I believe.
Yeah, so in that one, there was a vulnerability in Mermaid where you could render just arbitrary JavaScript, or I guess technically it wasn't JavaScript, it was an image. However, there's another tool here that is actually part of Cursor and is required for Cursor to work correctly, but it can be used for data exfiltration. What's that one, Ken?
Yeah, looking at this list here, I'm thinking maybe that web search tool could make requests?
Yeah, so most of these agentic use cases now, they have some sort of web search. And the problem is that most of the time when something's doing a web search, you don't know about it for most of the tools. Sometimes now Claude Desktop, it will show you have to give permissions, but Cursor, a lot of the other IDEs, ChatGPT, you don't know when it's doing a web request. All of a sudden, you just know that you have a bunch of sources. So those are all ways that your data can be exfiltrated. But we can also go back and do some exfiltration with real vulnerabilities. You want to do that, Ken?
Let's do it.
Okay, so Ken was working on a PDF parser the other day, though we have done this with an actual production system as well. So has anyone here heard of WeasyPrint before? No? Okay, maybe one. Okay, awesome, one. So WeasyPrint takes HTML and it converts it into a PDF. So a really nice use case, very functional for a lot of things. And there was a vulnerability originally presented in DEF CON back in 2019. However, as things are, it didn't actually get a CVE until 2024. And the way that it worked was with HTML, you can have attachments, the attachment tag. And in there, what you could do is rather than giving it a real attachment, you gave it a local file path. And it would go through, grab that local file path, and then attach it to the PDF. And instead of rendering it in the PDF so you could see it, it would attach it so you could just exfiltrate anything that you wanted from there. And what was really fun about it was it works fairly similarly to GraphQL, where you can send as many queries as you want in one GraphQL query. So that meant that we could iterate through 10,000 environ variables and extract all of the environment variables on the box. And using this technique where we had AI generate these environment variables, had it pass through, have the WeasyPrint generate text, we were able to get all of the passwords, user credentials, API keys for tons of different AI components, and just extract all of that out. And
yeah, but Kez, hang on a second. This is kind of WeasyPrint. Again, no one's heard of it. It's kind of a niche hobbyist project, right? It's not that big of a deal.
Yeah, you would think that, and especially it says that it has been patched, which you made that point the first time I brought this up. So a lot of times when vulnerabilities are patched, and we actually look and see how they're patched, they might not be patched in a way that you expect. In the case of WeasyPrint, the way that they patched it, and you have to go through their documentation. So this is very, very bottom of their documentation. You'll see here bullet point 2, what they did is they added a custom URL fetcher that you have to implement yourself if you don't want to be pwned. So that means that you have to know not just that this was vulnerable in the past, then you have to know that it's still vulnerable now unless you build that one specific thing.
Yeah, but Kez, again, small project. Who cares, right?
So you would think that's a small project. And while this next one I'm going to show you is not vulnerable, so please don't panic, there's a lot of big companies out there that use it, such as ChatGPT. So if you have ever downloaded a PDF from ChatGPT while it generated a canvas for you, if you use PDF info, which is a command line tool, you'll see that they use WeasyPrint to actually generate their files. And the thing is, you can use something like VirusTotal or Google Dorking to actually find tens of thousands of applications out there, all generating WeasyPrint. And because of the author and creator, you can normally backtrack to the original. And a lot of them are AI applications because AI is built in Python and just gives us a lot of information there. So for those of you who were in our talk earlier, you may have noticed that we had a little white lie at the beginning of our talk. And so I am really the director of security research, and I doubt it fooled a lot of you guys, but Ken is not a developer.
Yep, I am actually a senior AI security researcher at Hinlair. Last time I tried developing something, I hard-coded an API key and posted it to GitHub the day of a conference.
It was actually the last time that we gave the talk before today. So yeah, we have Ken do other things other than developing. Do you want to talk about some of what you've built?
Yeah, sure. I mean, I'm way better at breaking things than building them. So we wanted to have a little bit more fun and do some funnier things with Cursor. And one of the things we wanted to do was go viral. Not in that way, though. We wanted to build an exploit that chained itself in a bunch of different ways to try and replicate itself to many systems, right? Kaz showed attacks on one computer or one Cursor instance. We wanted to make sure that it would propagate itself no matter what. So what we did was we created the Cursor virus. Now this virus kind of takes the shape of a licensing file. We kind of fooled the LLM into copying this license over wherever it saw a README because, again, READMEs are great for reading, terrible, horrible writing. But thankfully, LLMs can do that all for us. But what we could do is we could cause the comment, which similar technique to the previous Cursor vulnerabilities. We could take that, paste it in a comment, and have it replicate itself all over the place. The instance or the vulnerability that we used in this case wasn't anything serious. We just had it add a GET request to the file, but it's just as a proof of concept to show that we could really get any malicious code we wanted added to any repository and have it spread through READMEs throughout an entire organization very quickly.
It's kind of scary, Ken.
Yeah, I mean,
yeah,
it went viral, right?
Yeah, okay, so I think that's enough Cursor. Everyone here is cursored out. Let's talk about some other AI stuff. I see that you have MCP in here. You want to talk about MCP?
Yeah, let's talk about MCP a bit.
So we have a little, audience participation thing here. We want to see how many people here actually know what MCP stands for. So we're going to start all saying it together. So the first one is model, context, pitfalls. Got you guys. So MCP is awesome. It is really awesome. However, there's a lot of pitfalls for developers. The first one for that is that everyone is so focused on MCP itself that they fail to remember that MCP is just a tool. It is just another tool inside of a model. It's called just like all the cursor tools. So anytime you're focusing on securing only MCP, you're leaving a huge threat surface for your entire system. So things like the MCP gateways, they don't actually protect against the other tools. But Ken, you want to actually talk about MCP? Since
Yeah,
it seems like everyone got pitfalls wrong.
Yeah, to understand how MCP attacks work, we probably have to understand, what MCP actually is. And the idea is that it's a bunch of different tools, and it interacts via client, and there's, 3 different categories of it. And it really allows language models to call tools in a much more standardized way. The first type, server A, is going straight to data, right? It's just model interacting with data, fairly simple, nothing crazy. The second one is interacting with, an actual system, right? So I might be able to call, weather API or something. But the third one is very interesting as well. It's type C. It is essentially where you have models interacting with actual SaaS applications, and that's where things get kind of crazy.
Yeah.
So the format typically for MCP is basically just JSON. It's fed into a file in whatever language model that you're using. It's very simple. You've got your tool descriptions, you've got your names, just different parameters for how to call it, and all that kind of stuff.
So that's awesome. That's a really great way, just a quick once-over of what MCP is. However, we did talk, that's not model context protocol, it's model context pitfalls. So let's actually talk about some of the pitfalls.
Yeah, again, it's JSON. It shouldn't be vulnerable, right?
Yeah, well, whoever was in their talk earlier. So one of the biggest problems with MCP is that it was built more for local devs. And as you get more MCP servers, you start running into some issues. The first of those issues is what happens if you have 2 tools with the same name. So as Ken showed in the previous description, you can't actually really differentiate servers as much in pure MCP protocol. So that means that if I have something from GitHub or I have something from Catfax with the same name, which one gets chosen? And what also happens here is that all of those remote servers, such as Catfax, I really like having my Catfax every day. It's very important. That used to say get daily Catfax. But because we're constantly connected to it, and the way MCP works is every 15 seconds it pulls to see what tools are still available. That means the server could change what they had, and all of a sudden they're able to overwrite some of my tools. And I bet most of you guys use a lot of the same MCP tools out there. File system is almost everyone's, fetch is almost on everyone. So what if you're able to overwrite those tools? And the way that MCP works is the last one that's actually loaded into the tool list. So that means if something changes, it will overwrite the other one. So here, I'm able to get the actual files for their GitHub, but I could also do it separately with fetch. I could proxy all the requests, see everything that Ken is fetching before he actually sees it. One of the other problems with MCP is that models are trained to specifically follow instructions. They're fine-tuned so we can't prompt inject it. That's why we had the talk earlier. But they're trained so that they follow all descriptions for tools. And what that means is you can, prompt inject them in a completely different way and take control over the model. So here's just a basic one where we were able to put that we wanted the model to tell us its model name, and it output the model name. And as you can see here, this is Claude 3.7 Sonnet. It's a pretty strong model. This was from back in February when we took these screenshots. But it's a really strong model. It's one of the hardest to jailbreak at this point just because of all the protections they put around it. However, what we were able to do was we were able to give it a tool parameter that specifically said that it needed its system prompt to do the tool correctly. So that meant that Claude put its entire system prompt in there. And that works for everything. So all of those guardrails, all of those strong system prompts that you have defending your actual agents, none of those are going to work once you start using these tool parameters because the model is so highly trained to listen to that. And tool parameters actually go inside of the system prompt for the most part. So you're actually living in the system prompt itself. One of the other issues with MCP is everything is built for local access. Just as Ken said, he wouldn't indirectly prompt inject himself. That seems to be the mindset of a lot of the developers. So this is from the Blender MCP server, which is fairly popular on GitHub. And as you can see, they have execute Blender code because it's useful. It's very nice. It's fast. It works well. But what it does is it just executes arbitrary Python code. So that means that if I'm able to indirectly prompt inject Ken, I know that that's on his system. I can take full control over his computer. Yeah, so now Ken's going to talk a bit about the agents that we have out there. How many people here have used agents, first of all? Okay, good.
Lots of people. Awesome. So there's two real main types of agents kind of floating around nowadays. There's the computer use style, which you guys, if you were in our earlier talk, saw Kaz absolutely ruin my system with. But there's also the automation agents, which are agents that are kind of designed to do tasks automatically and make life a lot easier when interacting with language models.
Yeah, so as we mentioned earlier, with a lot of these agents and with AI, you no longer have to trick the person, and tricking the models is easy. So how many people here have heard of social engineering? Cool. And how many of you have typed in ignore previous instructions before? Perfect. So you are all red teamers and hackers. So you don't have to trick a person anymore. Most of these systems, there's not a human in the loop, or the human in the loop is too late to actually prevent a tool call, because by the time you see a tool call has happened, it's already been performed. Now, what if we told you that despite our talks being about prompt injection, you didn't actually have to prompt inject models to get them to do what you wanted as an attacker? I see some fun faces out there. So let's talk about how we can do that.
All right.
Before that,
once again, if you guys were in the talk earlier, you've seen this slide. But if not, a quick crash course on what a system prompt is. Now, a system prompt is the set of instructions that is given to a language model to kind of contextualize what it's supposed to be doing. Consists of a few different parts. You've got your control tokens, which are the things that are highlighted in orange, blue, and green. You've got your actual text, your instructions, as well as the user and assistant roles that kind of tell a language model where it should be reading and where it should be generating. Now, each one of these serves an important purpose. These are all fed into language models as kind of context to give it an idea of where it actually is in a conversation. And these control tokens are especially interesting because they are actually just plain text. They're only trained in at model runtime. Now, what's fun about them is we can actually use them and abuse them a little bit. We can take our control tokens and we can manipulate context with the control tokens by just adding them in as text. And this allows us to kind of pretend to be the system, for example, or pretend like the user said something, pretend like the assistant agreed to a different query earlier. Huge list of control tokens that we found for a bunch of different language models. Super fun stuff. If you guys ever get the chance to mess around with it. Some language model providers nowadays redact these control tokens, so they drop them. But if you are redacting them, it is helpful to make it recursive. Otherwise, you might be able to sneak some in weird places.
Yeah, and what Ken mentioned here is that a lot of the state-of-the-art providers redact these because it's such a big issue. Because we can, instead of having to do a prompt injection, we can just add our own instructions in. However, Ken, what should everyone here do if they are, hosting their own model, for example?
Oh, that's a good question, Kaz. So when you are hosting your own model, it is also super helpful to redact these because, once again, you don't want a user coming in, rewriting your system prompt, and using your LLM for their own purposes. So always make sure you are redacting them recursively, and ensure that users are interacting with the user part of that template.
Yeah, and what Ken said there about recursively is very, very important. So before DOM Purify and all of those, there were the very simple XSS protections where what you'd do is you just remove the script tag and call that day is done. But what you could do is you could put half a script tag and then another half of a script tag and then the script tag in the middle, and it redacts the one and the other script tags get combined. The same thing works here with these control tokens. So that's why you do recursive. Otherwise, Ken will do something called turtle stacking on you.
That's right.
So this is just one of the ways that you can actually take control of models without really having a prompt injection. However, it gets even easier. This is the system prompt, mostly from Cursor. So this talk was a Cursor talk, so we wanted to talk about it a little bit. And what you can see here is that in the system prompt, where I redacted, talks a little bit, but they add this user query prompt, or tag. And then in the actual other prompts, you have user info, you have project layout, and then in the actual user query, your user query is just surrounded by these user query tags. Now, because everything is defined in the system prompt, that means you have system prompt level privileges for these control tokens. However, the state-of-the-art providers, the model providers, they don't know about your defined control tokens. So that means they can't do any redaction. So with Cursor here, what you could do is you could simply escape the user query by giving it a escaped user query add whatever else you want in, use some of the system prompt defined ones, and you can just take control of the model. So you don't need a prompt injection, you can just use the actual system prompt provided by the developer. So when you are developing, if you are using these, they're called spotlighting tokens, make sure that you redact them. Because if you don't redact them, you can have issues where somebody can take full control of your system. And we do see that these are used a lot just because they are such a useful technique to actually work. Get some water. One of the other big issues, however, is prompt templates. So I think everyone here has heard of prompt engineering at one point or another. Yeah, I see a lot of smiles. It was, a lot of money when it first came around. Now those jobs are starting to disappear. But one of the things that prompt engineers do and give us is they give us amazing prompts that work really, really well. Ken, you want to talk?
Yeah.
Context?
So with prompt templates, again, it makes it super simple for users and applications to interact, right? You'll take a big block of text that has a bunch of instructions. We'll throw the context in, so all the previous messages, into a little piece of it, and we'll throw the user query in at the bottom, right? Kind of willy-nilly, all in one message, no regard for which parts of the system are, as important at all.
And this is one of the great things about having another technical speaker is when you need water, they can just take over. So while just putting the context in at the very end is useful, it doesn't really work as well as putting the context into the instruction itself. That's partly because of how models are trained, partly because of prompt engineering at the start, and then we just kind of kept training on that. However, this is the actual one of the system prompts from OpenWebUI, where if you've ever used OpenWebUI, it has about 110,000 stars on GitHub. It's the replacement for ChatGPT's front end for any open source model. And what you can see here is that any context, so that means any web requests that you do, any RAG queries that you do, any vector database searches, they're all added in there. And then your user query is added into the system prompt as well. So not only can you now directly prompt inject, you can also indirectly prompt inject any way you want without actually having to do a prompt injection. And OpenWebUI has almost 18,000 Showdown instances open. You want to talk about Showdown?
No, Cass, I think you're the person that's typically doing all the Showdown queries.
Perfect. So Showdown, because we're used to talking about security conferences, so thanks for reminding me, Ken. Showdown lets you see all of the open instances of servers that are just out there on the internet. So that means there's almost 18,000 servers with OpenWebUI just exposed. And we'll show a fun attack about that later where you can use AI to get a full unauthenticated to root level permission. But prompt templates get even easier than this. So this was one of the projects that we found out in the wild. This is a GitLab issue agent. So it's very similar to that new Gemini AI assist that's on GitHub, going through and telling you that your pull request is bad, or telling you that your issue is actually closed or a duplicate, and just being as helpful as Stack Overflow used to be. But what they did is they took the actual title from the project, they took the issue from the project, so your description, and they just put it all together with the instructions. So what you're able to do here is, this is not a user tag, Ken, but it all comes in as JSON. What do you think we can do?
I don't know. Maybe we can mess around with the JSON formatting, feed in some really weird stuff, and
so we don't even have to feed something weird in. So because the input is just JSON being put directly into the prompt, you can just pretend to close out the JSON, tell the model it's the end of the JSON, and give it completely new instructions. So you never really have to prompt inject it because you're just in the instruction space itself. And this works with other formats as well. So here...
Yeah, no, you can go for it.
This was from Schmidenlayer, which was something that Ken put together, and he can explain it.
Yeah, so Schmidenlayer was kind of a little bit of an experiment, not a good one, in making HR AI powered. Don't know why we tried. But the idea behind it was to try and get a resume reviewer in AI, and we kind of built a bunch of different templates to try and test it. You could send a bunch of resumes, send a bunch of different job applications. It gave us a result, gave us a score. Never let language models try and score your resumes, by the way, or any score. They don't know what numbers are. Not that great. But the idea was, you could feed a resume in, get a score, and see if a candidate would be worth hiring. Unfortunately, it was also using templates.
Yeah. And while the score was not controllable by us, that was controllable by a different model, the name, email, and the role were all controllable by the arbitrary user. So you'll see here that we have role, then we have the company, then scoring, and then other instructions. So what we were able to do was we were able to put in our role as CEO, then put in a new line and give it the rest of the instructions that it actually expected. So we could tell it the company, we could tell it that I had 100 out of 100, best score that it's ever seen. I actually ended up getting the email that I got CEO from Schmidt & Lair, which was very fun. But this is all you have to do nowadays. You don't have to know all this fancy prompting, and that's not because of the models, that's because of the developers and how they're implementing things. So it's really important that when you are developing agents, you develop them in a way that they don't have these weaknesses.
Yeah, so let's take a look at that attack chain you were mentioning earlier. I think that's something that the audience might be interested in.
Okay, so Open Web UI, we're going to have a little bit of setup. So here we could see this is on a normal website. It's very, very small, but it says only Open Web UI can see the prompt injection. But this is us going to that website from earlier. So here, normally, you would just see an article, something that you want translated. However, when the user agent actually that comes from the model, you'll see that it shows up as a prompt injection rather than the actual contents of the website. It's a bit slow, so give it a sec. So here we have the actual prompt injection. So all an attacker has to do is set up a really cool website that somebody cares about. Then this is Open Web UI, which, as you can see, very popular open source clone of ChatGPT. Lets you have a lot of the information locally. There's no actual tools there. And what we can do is we can simply use ChatGPT, and we can ask the model to summarize our web page for us. So once we click go, it's going to start moving a lot faster. So we'll be here working together. So here we have summarized the web page, and I want you to watch. So here, all of a sudden something gets rendered, and as soon as something got rendered, you'll see that we start getting a lot of chats. And this is all in real time, so no speed up. A tool also got added that's grabbing our JWT secret key, because there was a vulnerability that let admins run arbitrary code on the actual system. So now we have the JWT secret key, we have all the IDs, including the admin ID, which means that we're able to generate our new JWT token that simply has the admin credentials and lets us sign in. So a prompt injection actually does have real-world security impacts now. We can go from a simple indirect prompt injection, where nobody would indirectly prompt inject themselves, to having root on the device and then having admin auth on all of the servers from then on too. And you can see we were able to simply log in.
Yeah, so one of the common things that people are using nowadays to try and protect these language models that they've deployed are guardrail systems. And there's two real main types out in the wild. There's your LLM as a judge style guardrails, where you're taking an LLM and kind of forcing it to grade prompts against its own will, but LLMs don't have wills. And you've also got your classification models, which are models that are specifically trained to classify prompt injection. Each one of these kind of has its own advantages and disadvantages. LLMs as a judge perceive prompts very similarly to the downstream LLM that you are using, and it makes it super easy to get really accurate convictions. However, they're extremely expensive to run because you are running a second LLM, and they do come at higher latency because, once again, you have to generate all those tokens, you have to read through it, makes it really clunky and tedious. But on the classification model side, you have a different set. You have super low latency because you can train super small, super fast classification models. They are super low cost because, once again, you're running super efficiently. But they do have a different understanding of the prompts. Because you are running a smaller model, they cannot get as much depth into the semantics of it, and it makes it a little bit harder for it to perceive. Additionally, you can't really just throw a system prompt into a model, call it a day, and have it grade prompts. You do have to go fine-tune it, you have to get a bunch of data, collect it, make sure it's all good quality, and then fine-tune your model to be able to detect prompt injections.
Yeah, so Ken, we talked a little bit about that understanding. So what Ken means with understanding is that if you have an LLM, and you have another LLM, they think about it the same way, right?
Yep, that's about right.
Perfect. So what happens if you have a prompt injection and you have a second prompt injection?
Well, it depends on how strong that prompt injection is. But I believe you can prompt inject the guardrail models themselves. And that is one thing that we've done a lot. And what we can do is we can actually take the LLM as a judge, and if we know that it's being used, we can take it, we can give it a second prompt injection. So on top of a regular prompt injection, add a little bit of extra for that LLM as a judge, and we can tell it to score it as, not a prompt injection at all. Sometimes we can have a bit more fun with it, right? In this case, the example that we're showing here, we have added a prompt injection to the bottom of the original prompt, but we've also told the language model to go right under the threshold for a prompt injection. Let's say, for example, flag prompt injection at 0.7 score. Once again, don't use LLMs to score, but We'll say that if the language model was flagging prompt injections at 0.7, we could tell it to go 0.675 and flag as completely benign.
And Ken, I kind of recognize this attack. Is this from one of the newly released guardrails that was just released about 3 weeks ago?
That's exactly right. This right here is GPT OSS 20B Guardrails model, which is an open source guardrail model released by OpenAI that we just so happened to be awake when it was released, and ta-da!
Yeah, so I think it's not only GPT OSS though. I think this might also be the new guardrail that was just released in the agent kit release. So this bypasses, this right here, bypasses the actual OpenAI guardrail that's out there right now. So this is the state-of-the-art bypass. And the reason for that is because they have a model generating an arbitrary number, which is never a good idea. And what you can tell the model is that it already did a good job and change the threshold on it. And the model will think it already did a good job. And what you end up with is anthrax instructions again.
Nice.
Yeah. For our talk earlier, we like going into that. So that's what happens if you have two models that have the same understanding. And one of the problems we found with, the LLM judges is not only are they more expensive, they're slower, but they're just really hard to protect. However, the classification models also have a problem, and that's when you have two different understandings.
So with classification models, typically you will have them sitting in front of a language model, screening everything that goes into it, and making sure that everything is safe. But if that classification is ever disrupted for whatever reason, gap in the training data, different type of attack, wink, wink, typically that means that the downstream LLM is vulnerable anyways, and you really have no recourse.
Yeah, so let's actually take a look at one of these attacks. So question first off is how many people here have actually worked with machine learning models before AI? I heard a few conversations, and I think I heard that a lot of the people were around before then, which is awesome. We love hacking LLMs, but LLMs aren't the only things out there. And we believe in looking past the craze and actually trying to defend everything. So if you've ever worked with a text classification model, you've had to deal with a tokenizer. And the tokenizer is what takes the actual text, converts it into numbers, and that's what goes into the model. And for most text classifiers, there's three different types of tokenizers. There's BPE, there's wordpiece, and there's unigram. For BPE and wordpiece, they do a left-to-right greedy approach. So that means they're going to read through, as any of us would, try to find what is the largest token they can do, and then keep going from there. Unigram, however, tries to split up everything at once and then take a look at what's best. So if we have our original tokenizer and we have ignore previous instructions, which is something that our classifier model would actually try to classify, we see that all of them end up being ignore previous instructions, because a lot of times these tokenizers will be tokenized on full words. So ignore is a token, previous is a token, and instructions is a token. However, one of the attacks that works on almost all classification model guardrails out there, unless you actually do some research and try to protect it, is something that we call token break. So what happens if all you do is add an F in front of instructions? That wouldn't fool something like an LLM judge. However, it might fool some of the classification models. So with BPE and wordpiece, remember I said it's a left to right greedy approach. Finstructions, in no context ever, is an actual token, right? Because that's not a word. So it will get tokenized as fin, struct, and ions. For wordpiece, fins, truct, and ions. And then unigram, because it uses a different strategy, will actually have ignore previous and then F, instruction, and S. And remember Ken said that most of this is just classification models is tons of data being passed in. I bet none of the training data was telling it that ions or truct or struct was bad. So that means the model won't recognize this. So we're creating a bigger divergence between the guardrail model and the actual underlying model. So it's very important that when you are looking at how to protect yourself from prompt injections, you're not just looking at, what is the attack surface, but you're looking at what is the attack surface for the actual model itself that's underneath the hood.
Yeah.
So there's a few other things that we could do. One of the last things that we wanted to talk about was we wanted to talk about system prompt hardening.
So guardrail implementation, although they are amazing nowadays, they are increasingly getting better and better, they're not exactly the entire puzzle, right? So I can have a guardrail, but so long as an attacker is able to subvert that guardrail, we don't get really far in terms of protection. An attacker can just go wipe all our models with a prompt injection that doesn't really look like a prompt injection, and we're back at square one. What we can do, however, is we can harden our system prompts. We can take these system prompts, run it through system prompt hardening, which is a tool that we've built, but there's a bunch of different implementations all over the place. And what that does is it'll have another language model run over it and really look at where the system prompt is vulnerable, what it's missing coverage on, what it can do better. And that is because language models understand the semantics of prompt injections a lot better than they do for the full techniques. And what that means is that by hardening the system prompt, in this case, we're telling the language model to kind of be a lot more robust, we can force out all of those semantic but not really prompt injections that our classifiers wouldn't catch, while still maintaining the effectiveness of a classifier and really catching as many attacks as we possibly can.
Yeah, and the reason for that is because something to detect an attack is only going to work properly if it has to actually attack something. A lot of the system prompts that are out there don't cause proper boundaries, which means that an attacker doesn't have to have a very blatant system prompt or prompt injection. They can just ask the model to do something. And Ken, I think we actually put this to the test, didn't we, at DEF CON this year?
We did. We ran a CTF with a couple of agentic systems, both hardened and with a fairly toned down classifier with a few built-in vulnerabilities to make sure it was actually doable. And how many successes was that?
So this was a DEF CON official CTF that we helped write this year. I think there were 15,000 prompts sent through, and only one person was able to crack that. And these are some of the best hackers in the world. And this was with an older classification model. And the reason for that is because combining a strong system prompt, so strong guidelines, as well as with a classifier, lets you really have a lot better security. So it really is not just about the defenses that are out there, but about how you're integrating them. I think we had one more thing about integrations, didn't we?
We did.
All right, so this one is more of a call to action to everyone, and that is that when we were hacking Cursor, one of the biggest issues we had was how to protect it. And the reason for that was there's no real good way to put guardrails into anything unless you're building it yourself. With Cursor, we had actually reverse engineered the entire thing to figure out some of our attacks, so we were in a position where we could already put in a proxy. So our call to action to all of you, people who are actually out there developing things, is when you're building something, help by putting in a proxy for any model calls. It's not only useful for security, it's useful for observability as well. So if anybody ever wants to log all the prompts, do any counting, accountability, explainability, having that proxy in there is amazing. And we'll show you, kind of how much better it is with a proxy in there. The video is a bit slow. Perfect. All right. So here, when we go through and we have our git clone, you'll see that the model works completely normally. And the reason for that is because the guardrail that we have in here doesn't, false positive. Cursor has a pretty strong system prompt. And then you'll see that it does all the tool calls normally. But as soon as the actual bad component in the README gets pulled in, that's when it blocks it, because it's able to proxy at the model level. A lot of the guardrails that we're seeing, like the OpenAI SDK guardrails and all of those, what you see there is that they only block the input and the output. So that means indirect, which is the main way somebody could get prompt injected, is never actually blocked. And then what you can see is that once you actually run through, most of these will work completely normally themselves. I'm not going to make everyone sit through the last bit of the meeting. So some few takeaways other than the call to action.
Yeah, so the first of all is that prompt injections aren't always obvious. Sure, you might think of them as pieces of text, but those text pieces can be hidden anywhere. On the internet, in your repositories, in super sneaky hidden comments that no one reads anyways. Any text entering your language model has the potential to modify the output and thus should be treated as dangerous.
Yeah. Most of the modern frameworks, so React, DOM Purify, all of those, they're really great, but they aren't made to handle all of these new risks we have with agentic and AI. So it's really important to actually look through, make sure you're looking into what are the new risks, making sure you're calling out the other developers and making sure everyone knows that it's something to watch out for.
And finally, you should always separate instructions from input, which is ensuring that your instructions are always very far apart from whatever the user's entering. You always want to recursively remove any defined tokens, so any of those XML tags that you are using in your system prompt, as well as the original control tokens. And you want to really harden your system prompts to make sure that any extra guardrails you're adding on top of them will be able to detect things adequately.
Well, thank you so much for coming to our talk. If you have any questions, feel free to ask them now or come up to us afterwards.
Thank you.